Hey, it's Mr. Ard, and now we're solving rational equations. We've been simplifying expressions, but now we're going to solve equations. So we're going to find x. So we've done this before. We actually did it at the beginning of the semester. But what we have here are a couple of steps to help us solve rational expressions. And that would be to multiply the entire equation by the least common multiple or the common denominator to get rid of the fractions. So if you remember when we solved linear equations, sometimes we had a fraction, maybe it was like a 1/2, and we didn't like having fractions there, so we'd multiply through to get rid of the denominators. We're going to do that here. After we get rid of the denominators, we're going to solve the equation in whatever way we normally would. And then for the way we're working here, we need to check our answers to make sure they work, because we can pick up extra answers here like we picked up when we solved the root equations. So let's see how this works. So here we got the equation. It's the fraction x over x minus 2 plus the fraction 1/5 equals the fraction 2 over x minus 2. So what we want to do is get rid of all the denominators so we no longer have to look at a fraction. Excuse me. So when we look at these, we see x minus 2 as one of the denominators, and we also see a 5. Hold on. I apologize. I had to cough really bad there. But we have the denominators x minus 2 and 5. So we're going to multiply the entire equation, both sides, every term, by x minus 2 and 5. So I'm going to write that out with every term. So the first term here is x over x minus 2. And if I multiply that by x minus 2 and 5, what's going to happen there is I'm going to be able to cancel out an x minus 2 on top and bottom. I have to move it to the next term, which was 1/5. I'm going to multiply that by 5 and x minus 2. And in that case, I'll cancel out the 5. And then on the right hand side, I have 2 over x minus 2. And when I multiply it by x minus 2 and 5, the x minus 2 will cancel out. So let's see what's left here. So in the first one I have 5 times x, and the next one I have 1 times x minus 2, and the last one I have 2 times 5, which would be 10. So I have a simple linear equation here. And if I collect like terms, 6x minus 2 equals 10. Bring something over, x equals, bring the 2 over, 6x equals 8, and then x equals 8/6 or 4/3. Okay, so we started off by multiplying through to get rid of the fractions, and then we really like the equation when the fractions are gone. Now, we can pick up extra answers here. We need to make sure they don't make the denominator 0 here. So in that case, if we look at what we had, x over x minus 2 plus 1/5 equals 2 over x minus 2. Let's focus in on the ones that have an x in the denominator, the x minus 2. So the real problem here is that if you get 0 in the denominator when you plug your answer in, then it would be undefined and does not work. But our 4/3 would work because 4/3 minus 2 is not 0 in both places. Okay, the 5 can't be 0, so we have an acceptable answer here. So x equals 4/3 is a good one to keep. All right, let's do another one. This one is the fraction 1 over x minus 4 plus the fraction x over x minus 2 equals the fraction 2 over x squared minus 2x plus 8. So I need to multiply through by a common multiple. So let me look at these things. X minus 4 can't be broken down. X minus 2 can't be broken down. but x squared minus 2x plus 8 can be broken down into x minus 4 times x minus 2. So I'm going to multiply through by something that will cancel the denominators out, but I don't want to multiply by too much. So if I can factor something and figure out that I'm already using those factors, I won't make my problem more complicated than it needs to be. So in this case, I'm going to multiply the entire thing by x minus 4 times x minus 2 because I have a denominator of x minus 4 and I have a separate denominator of x minus 2, and this will allow them to all go away. So I'm going to write a little bit different this time. So when I do the 1 over x minus 4, I'm just going to go ahead and write it as 1 times x minus 4 times x minus 2 all over x minus 4. And we can see something will cancel out, the x minus 4. The next one plus x, and that'll be times x minus 4 times x minus 2. And that'll be all over x minus 2, so I see another factor canceling out, this time x minus 2. And then lastly 2 times x minus 4 times x minus 2 over x minus 4 times x minus 2. And in this case, both the x minus 4 and the x minus 2 will cancel out. And if you look, all my denominators are gone. So let's see what this cleaned up into. The first one be 1 times x minus 2, which is x minus 2. The second fraction numerator is x times x minus 4, so that would be plus x squared minus 4x. And then that would be equal to the right-hand side, which is 2. So I'm going to pull everything to one side and have a quadratic of x squared minus 3x minus 4 equal to 0. And in this case, I can factor that. X minus 4 times x plus 1 equals 0, so I get two answers. X equals 4, x equals negative 1. And I said we need to make sure nothing goes wrong with these two. So if I look at this x minus 4, I notice that it doesn't work in this denominator where I have an x minus 4. So I'm going to have to throw it out. Now the negative 1 does not make any of my denominators 0, so that is the answer I get and I get to keep. Alright, I'm going to say some more examples for the next video.